In this video, we're going to do a Lagrangian utility maximization problem where the utility function takes on this form. So here's our utility function. We could rewrite it. Instead of having minus 1 over x following the rules of exponents, it just becomes minus x raised to the minus 1 power. And here's our problem. We want to find the utility maximizing consumption bundle. We're going to assume the consumer has income of $40, the price of good X is $4 a unit, and the price of good Y is $16 a unit. Setting up the Lagrangian, here is our objective function, the utility function, subject to the constraint, and we're going to enter the constraint in as follows. It's going to be the income minus the price of good X times units of good X minus the price of good Y times units of good Y. Substituting our values into the constraint, M is 40, the price of good X is 4, and the price of good Y is 16. We're going to take three partial derivatives. The first one we take is a partial derivative of the Lagrangian with respect to good X. Doing that, this minus 1 over X becomes X minus 2. Easier way to see that is just bring this minus 1 down in front, so the minus and the minus becomes positive, and then we subtract 1 from this exponent, leaving us with x raised to the minus 2. And then we have this lambda being multiplied by minus 4x, and the derivative of that with respect to x is just minus 4 lambda. And we set this equal to 0. The partial derivative of Lagrangian with respect to good y is going to be 1. Partial derivative of y is just 1, and then we have left over here minus 16 times lambda, and that comes from the fact that this lambda is being multiplied by minus 16 times y, so taking the partial derivative of that with respect to y, the y cancels and you're just left with the minus 16 lambda. And then the final partial derivative, we take that with respect to lambda and just get back what's in parentheses, the constraint. So the first thing I'm going to do, I'm going to take this first partial derivative result right here. I'm going to solve it for lambda. So a little algebra solving for lambda. We get this result. And then likewise, I'm going to take this middle partial derivative result and solve that for lambda. And we get 1 over 16. Now we got two lambda equations. Set lambda equal to a lambda. And now we're going to solve here for x. So doing that over here. So again, after setting lambda equal to lambda, and now solving for x, multiplying through by 4, following the rules of exponents, bringing that x down into the denominator, simplifying the right-hand side, and then multiplying through by 4 and multiplying through by x squared. And then taking the square root of both sides, x equals 2. We're going to take this x equals 2 and plug it back into the consumer's budget constraint. And here's the consumer's budget constraint. So where we have x, we'll plug in 2. And now we're going to solve this for y. So 40 minus 8 leaves us with 32. And dividing through by 16, y also equals 2. So that is our utility maximizing consumption bundle. And if we wanted to calculate the level of utility at that consumption bundle, evaluate the utility function at x equals 2 and y equals 2, and you get 1.5. Okay, that's it.